Okay, this is 7.2 homework help. This is the first problem that says that the sine of theta is equal to x over 6. So we're going to draw that, and it says that we're in the first quadrant. So we're going to draw a reference triangle in the first quadrant and label the sine as opposite over hypotenuse. We can do the Pythagorean theorem then to get this side as the square root of 36 minus x squared. And now we can answer this. It wants the cosine of theta in terms of x, so cosine's adjacent over hypotenuse, so that'd be square root of 36 minus x squared all over 6. And tangent's opposite over adjacent, so that'd be x divided by the square root of 36 minus x squared. Okay, the next problem, we're not going to verify a trig identity, we're just going to simplify this. So I'm going to take this and rewrite everything in terms of sine and cosine. So tangent's really sine over cosine. I'm going to flip this to the top and rewrite it as cosine over sine. So if you move this to the top, then I reciprocate it. So it'll be cosine over sine. Alright, now I can get a common denominator by multiplying the top and the bottom of this one by cosine. And so what I'll have is 1 minus cosine squared in the top divided by sine of t cosine of t. Now this top 1 minus cosine squared, if you look at your formula sheet, right here, this first Pythagorean identity, if you subtract cosine squared, you get sine squared equals 1 minus cosine squared. So what this is really is sine squared. And then one of these sines will cancel with one of these. So my final answer is sine of t over cosine of t, which is just tangent. So this is the work that I would look for on a test. And your answer would be tangent of t. Alright, the next problem I'm not a super big fan of. I probably won't give you a problem like this, but to verify this one, we actually kind of walk through the steps that they give us, and it actually uses both sides of the equation. I like to start with one side and prove that it equals the other, but this one's kind of weird. But what they do is they say, okay, well, take this right here and now move it to this. So basically get sine on the left side by itself. To get sine on the left side by itself, you'd have to multiply both sides by 1 minus cosine of t. And that way this would cancel. And so on the right, this right here has to equal this right here. So you have this is right here, so you have to write 1 minus cosine of t right there. Now for the next step, if you compare this right here on the right side of the equation to what was on the right side of the equation, you'll notice the sign's missing. So we have to multiply both sides by the sign in order to cancel it, in which case that's what we do here. And then the last part, if you look at the left side is sine squared, the right side then becomes something else. So we want to simplify this. In order to simplify the right side, we can just FOIL and you get 1 minus cosine squared of t. So that's what we want right here. Which 1 minus cosine squared of t is really sine squared of t, and that's right off your formula sheet right here. If you subtract cosine squared from both sides, you get 1 minus cosine squared equals sine squared. Okay, the next problem is similar, where it gives us this equation right here. And first it wants us to move the tangent over. So we add tangent to both sides here. And then next it says find the common denominator. So basically we're going to rewrite tangent as sine over cosine. And then add this together. So tangent's now sine over cosine, so it's 1 plus sine over the bottom common denominator cosine. And then from there we can cross multiply. On the left you get cosine squared, on the right you get 1 minus sine squared. If you FOIL out this 1 minus sine times 1 plus sine, you're going to get this right here. And that's equal to cosine squared. So now we've verified the identity. Okay, the next problem, I've wrote all the answers down here. And if you wonder where these come from, these are formulas that we're going to cover in the next section, right in our formula sheet. So they're all in the formula sheet. For example, here is our cosine of sum and difference formula. So if you have, for example, the first problem says, or how about this one, says cosine of a plus b. Well, cosine of a plus b, you would just change u for a and b for v. And you're using the plus sign, so you'd follow the top part of the formula. So it would change to a minus sign here, which is what I have right here. So that's where I'm getting all these right off the formula sheet. They're all trig identities that we're going to use in this next chapter. So all you have to do is locate them on the formula sheet and copy them down. So this sine of 2u is equal to this right here. and that's the first one. Instead of U, we're using C though, and make sure you use a capital C when you go to enter this in. Use capital letters. For some of these formulas, there's multiple formulas you can use. For example, the cosine of 2u, there's 3 different formulas you could choose from, and Webwork should accept all of them if you enter them in correctly. But the cosine of 2c is right here, so I just used the top one. And make sure when you enter this in, you put parentheses and do caret squared instead of the square right here. Alright, next one I'm going to simplify these, so FOIL it, and you get 1 minus sine squared of t, which that's just cosine squared of t from your Pythagorean relations on your formula sheet right here. Alright, the next one I'm going to FOIL this as well, and I'm going to end up with tangent squared of t minus secant squared of t, because the middle terms will cancel. And now if we compare that to this formula right here, and if we move tangent over, subtract tangent from both sides, actually if we move secant, let me just write this down. So here's the Pythagorean relation from our formula sheet. So if we want to get it to look like this, we can just subtract secant from both sides. So we'd have tangent squared of t minus secant squared of t. And then we can also move this to move the 1 to the other side as -1. So what you can see is this equals -1. And then the last one, you get secant squared of t minus 1, which is on your Pythagorean identities again. If you subtract 1, that's just tangent squared, which don't forget we have to enter that in squared like this. Like that. Okay, for some of these in the next problem, I'm going to simplify. So this first one, I'm going to divide sine into both. So I have sine of x over sine of x plus cosine of x over sine of x. This simplifies to 1, and cosine over sine is cotangent. So we'd have 1 plus cotangent, which is d. Next problem, similar to the one we just did, we get 1 minus secant squared of x, which is, if you on your Pythagorean identities on your formula sheet, 1 minus secant squared, if you move the tangent over to the right, would be negative tangent squared. So it would be negative tangent squared of x, which is b. Okay, the next problem, cosecant is 1 over sine. So we can rewrite this as 1 over sine divided by sine. Now instead of dividing by sine, let's multiply by 1 over. So basically we get 1 over sine squared, which that's really just cosecant squared of x, but that's not up here. So I'm going to have to try again, try to simplify this a different way. So let's try something else. Alright, I actually wasn't able to simplify 3, so let's move on to 4 and try that one, and that way the one that's left over will be 3. But if we simplify 4, we have cosine of x minus secant's 1 over cosine, all divided by secant, which is 1 over cosine. And now I'm going to move this to the top by multiplying, so I'm going to multiply by the reciprocal, which would be cosine. So that gets rid of this in the bottom because I'm multiplying by cosine. And when I distribute through, I get cosine squared of x minus 1. And that's c. That's negative sign. And that's right off your formula sheet, because if you look at the Pythagorean relation, when you subtract 1 right here and move the sign over to the right side, you get negative. So if you subtract 1 and move sign over. So obviously then the last one is a here. Alright, the next problem I'm going to do the same thing. I'm going to simplify this. The first part turns into, alright, so I replace cotangent with cosine over sine and secant with 1 over sine. Then these cancel and I get cosine of x minus, and these cancel and I get cosine of x here, so that's just 0, which is b. Next one, I'm going to do the same thing, rewrite this right here by replacing tangent with sine over cosine and cosecant with 1 over sine. And then one of these cancels with one of these. I'm sorry, I missed this cosine right here, so that's still there. And these cancel, so I end up with sine of x plus sine of x, which is just 2 sine of x, which is a. And obviously the last one has to be c then. And you could try to rearrange this if you want for extra practice. Alright, so here's the work for that one if you want to follow along. It's the hardest one, but you'd have to FOIL this out and then, replace 1 plus cotangent with cosecant, write it as 1 over sine. Sine squared is really 1 minus cosine squared, and then do the difference of 2 squares pattern to get all the way to this. But that's a good practice one, I guess. Okay, the next one we have to rewrite these as with our properties of even and odd functions. So the first one, cosine's even, and even functions have this property where you stick in a negative x, you get the regular function out, and odd functions have this property where you stick in a negative x and you get the opposite of the function. So this is what I'm using right here. Even functions, the negative sign goes away, and odd functions, the negative sign comes out front here. So with that, these add together to be 0. So the next one then, secant's 1 over cosine, so it's going to be even, just like cosine. So that negative is going to go away. I'm going to have secant of x minus secant of x, which is just 0 again. And then the last one, cosine's even, so that negative goes away, and I have cosine of x plus cosine of x, which is just 2 cosine of x. Okay, the next problem, I'm going to simplify all these. The first one, I'm going to rewrite 1 as cosine squared over cosine squared, so I have a common denominator. Then I'm going to subtract, and I get this. And now, if you look at your Pythagorean identities, this in the top would be negative sine squared of x, which turns into negative tangent of x. So the next one, I'm going to rewrite the top. I'm going to rewrite cosine squared as this right here, because that's right on your formula sheet right here. If I subtract cosine over and subtract 1 over, I get this. And then if I distribute the negative, the signs would cancel, and I'd get positive 1 in the top. Actually, I had this wrong. This should be 1 minus sine squared if you look at the formula sheet. And then I can also do the same thing here, replace 1 minus sine squared for that cosine. And what I get is this. If I distribute the negative sign, I get this in the numerator. And then if I plug this in right here for cosine, I get this. Now I can simplify the bottom and the top. So if you distribute the negative 2 to both of these and rearrange, you get the same thing at the top that you do the bottom. So your answer is just 1. And then the last problem, I'm going to factor out a cosine first and change the bottom into 1 over cosine. And then I'm going to multiply by cosine instead of dividing by the reciprocal, which just gives me cosine squared. Right now this is just 1, so your answer is just cosine squared of x. Okay, the next problem, first one, I factored out a tangent from the top, and then I also, because the cotangent's an odd function, I pulled out a negative sign. So this is negative 1 then off the Pythagorean identities. So I get negative tangent over negative cotangent. Double negatives cancel. I'm going to multiply by tangent instead of divide by cotangent because they're reciprocals. That just gives me tangent squared. All right, the next one, I'm going to factor that into the difference of 2 squares. And then this goes to 1. And this is just going to be what's left over, so I'm going to enter that in right here. All right, now for some reason it wouldn't accept this answer. So let's replace cosine with 1 minus sine squared off the Pythagorean identity and simplify, and then you get negative 1 plus 2 sine of squared of x. Don't ask me why, but for some reason it likes this answer better. I think this answer is just as simplified, but let's use that answer. Okay, the next problem then right here, I'm going to rewrite secant as 1 over cosine squared and tangent as sine over cosine, and then multiply by the reciprocal of this, in which case the cosines cancel, and I get 1 minus 1 over sine squared, and I'm going to get a common denominator here, so I end up with this right here. Now this top becomes negative cosine squared of x if you use the Pythagorean identities. And so I have cosine over sine, which is negative cotangent of x squared. All right, I'm going to have to go faster this next one. So you set up this, call this theta right here. So then you can say cosine of theta equals 4 over 5 and set up this reference triangle. Cosine is 4 over 5, and then this is 3, Pythagorean theorem. Then you can find the sine of that angle is opposite over hypotenuse 3/5. So the next one would be 5 over 12. Tangent of that angle is opposite over adjacent. All right, the next one, cotangent's odd. Cosine's even and sine's odd, so I can simplify it like this. Now, cotangent's cosine over sine, so I can multiply and make it cosine squared over sine. Get a common denominator, and I can add the top together and simplify. Pull out a negative sign, and now I can cancel negatives on both sides of the equation. This is just 1. So now we can see my answer is just sine. So the last problem, if you set this up, draw a reference triangle in quadrant 3, tangents opposite over adjacent, which is square root of 28 over 6, and cotangents adjacent over opposite, so 6 over 28. These cancel and you just get 1. All right, the next one then is cosecant's the reciprocal of sine, so it's hypotenuse over opposite, which is negative 8 over square root of 28, and tangents opposite over adjacent, so it's negative square root of 28 over negative 6. Square root of 28 is canceled. 2 of these negatives cancel. I get negative 8 over 6. And the last one, we know that sine squared plus cosine squared is always 1, but you could actually do it out here. In which case, here's the work for it. Sine squared plus cosine squared ends up giving you 1 still. All right, I hope this helped.